So back in early 2023, the AI world was all about the giants. Think massive, massive models. But then Meta AI drops this paper, pretty quietly, called LLaMA. And it wasn't just another paper. It laid out this totally new, super efficient way to build powerful AI. And honestly, it completely changed the game. So let's get into it.
So here's the big question the LLaMA paper basically threw out there, and it's kind of mind-blowing. What if you could build an AI that's 10 times smaller than something like GPT-3, but it was actually better? I mean, it's the classic David versus Goliath story, right? Could this tiny, lean model really go up against the behemoths and win? Well, the answer surprised pretty much everyone.
Okay, so to really get why llama was such a shock to the system, you've got to understand what was going on at the time. In the world of large language models, the mantra was simple: bigger is better, always. The thinking was, the more parameters you have, the better your model will perform. And that just kicked off this insane arms race to build the biggest, most enormous models anyone could imagine.
And yeah, this really shows you just how massive the difference was. A good way to think about a model's parameter count is like all the little knobs it can turn to learn and get smarter. So you had the Goliaths, right? Google's Palm with a staggering 540 billion parameters, GPT-3 with 175 billion. And then you have LLaMA, the challenger, coming in with a range from just 7 billion up to 65 billion. It's not even in the same league size-wise.
So, the obvious question is, how on earth could a smaller model even hope to compete? Well, the whole idea behind LLaMA was to challenge that bigger is better rule head-on. They figured, maybe it's not about building a bigger brain. Maybe it's about feeding it a much, much better diet.
And this quote right here, this is the light bulb moment that really inspired the whole project. The LLaMA team saw this research, and it basically said, hey, for a set amount of computing power, you don't get the best results from the biggest models. You get it from smaller models trained on more data. And that was it. The key insight. Maybe everyone in the AI race was focused on the wrong thing.
I love this analogy because it makes it so clear. The LLaMA approach wasn't about building a super genius brain and giving it a tiny bookshelf. Nope. It was like taking a standard-sized brain, a really smart student, and giving them a library the size of a city to read from. The bet was that just soaking up all that extra information would make the smaller model way more capable.
Now, under the hood, they also made some really smart technical tweaks. We're talking about things like using something called RMS norm for better training stability, a swigglue activation function to boost performance. They didn't have to reinvent the transformer architecture, they just made these clever, efficient little improvements. And all these small details added up, helping them squeeze every last bit of performance out of those smaller models.
Okay, so this is where it gets really interesting, because we've got the theory, but what about the practice? One of the most important things about the LLaMA project, something that really set it apart, was its commitment to using only publicly available data, no secret sauce.
And just look at this data diet. The vast majority, 2/3 of it, came from Common Crawl. That's basically a snapshot of the public internet. Then you've got big chunks of code from GitHub, articles from Wikipedia, books, scientific papers, the whole shebang. And this was a massive deal. Using only public data meant anyone, any researcher, could check their work. It wasn't hidden away in some proprietary data set.
And the sheer scale here is just wow. We're talking 1.4 trillion tokens. A token is kind of like a piece of a word, maybe 3 or 4 characters. So yeah, that's an absolutely astronomical amount of text. When we use that library the size of a city analogy, this is what we were talking about.
All right, so the stage is set. We've got our challenger, smaller, leaner, but fed on this massive public library of data. Now for the main event. How did LLaMA actually stack up against the giants when it came to the benchmarks? You know, the standardized tests that are supposed to measure AI performance.
First up, a common sense reasoning showdown. This is all about an AI's ability to understand and reason about just normal, everyday stuff. And trust me, this is something that's notoriously tricky for AI to get right.
And boom, right out of the gate, an upset. Just look at these numbers. LLaMA 13B, the model with only 13 billion parameters, remember, that's over 10 times smaller than GPT-3. It actually scores higher. It was better at a really tough language task. That's a clear win for the little guy. Incredible.
Okay, round 2. This time, it's a closed-book question-answering test. The models have to answer questions from their own internal knowledge, no looking things up on the fly. This is a great test of what a model has actually learned. And
would you look at that, it happened again. Another stunning result. LLaMA 13b doesn't just beat GPT-3, it beats it by a pretty wide margin. This really seems to prove their theory, right? That training on more data made the smaller model's knowledge deeper and easier to access.
I mean, you don't even have to take my word for it. The paper's own abstract says it all. This one sentence right here, it sent absolute shockwaves through the AI world. LLaMA 13b outperforms GPT-3 on most benchmarks, despite being 10 times smaller. This wasn't a one-off. The little model was consistently punching way above its weight class.
But you know, the story doesn't stop there. The incredible performance was one thing, but maybe the biggest impact of LLaMA came from what Meta did next. They actually released the models. They opened up the black box for everyone to see.
See, before this, the biggest models were kept under lock and key. They were proprietary black boxes. Sure, you could pay to use an API, but you couldn't really look inside or study how they worked or build on top of them. By open sourcing LLaMA, Meta basically handed the keys to the car to the entire research community.
So why was this such a big deal? Well, for one, it completely democratized access. Suddenly, universities and indie researchers could get their hands on a top-tier model. It also meant people could do really important research into model safety and behavior. And maybe the craziest part? The 13B model was so efficient you could run it on a single high-end GPU. That was just impossible with the giant models. This one move kicked off an absolute explosion of innovation in the open source community.
Now, of course, we have to talk about the responsible side of things. Building these models has real costs, both for the environment and, ethically. And, to their credit, the LLaMA paper was super transparent about all of this.
I mean, training these things takes a ton of energy. The paper calculated the carbon footprint for training the 65B model, and it's pretty significant. But to be fair, when you compare it to another big open model at the time, Bloom, it was actually in the same ballpark. It just goes to show you the kind of massive resources it takes to push the boundaries of AI.
And they were also really upfront about the model's flaws. Because when you train on a giant chunk of the internet, you get the good and you get the bad. The paper openly acknowledged that the models picked up on societal biases, they could generate toxic stuff, and of course, they could hallucinate. Just make things up with total confidence. They didn't sweep this under the rug, they laid it all out for other researchers to work on.
Which really brings us to the final big question that this paper leaves us hanging with. What does it mean for the future of AI if smaller, open models can actually outperform the giants? LLaMA proved that the race isn't just about who can build the biggest thing. It's about being smarter, more efficient, using better data, and being open. It totally shifted the conversation, and by proving that David can beat Goliath, it really opened up the future of AI for everyone.